Familiar with the drill. 15 minutes to do your presentations, 5 minutes Q&A. We're all on Zoom so we can keep track of time. We're going to start with VESP, then vrcules, and then we'll end our finals with archive dive. So VESP, if you are ready, you can turn your cameras and mics on, and I will find you and spotlight you. There she is.
Couldn't you
all right, that's all of you.
Can we get screen sharing permissions, please?
Oh, fine. Yes. You got it.
Thank you. Right. Are you ready to start? Or?
Yep, whenever.
All right. Hi, everyone. We are VESP, which stands for Virtual Extended Sensory Palette. We're a student pitch project united by a passion for nature and the natural world. And our goal was to try to capture some of the things that make nature amazing so that we can inspire passion in others just like us. This is a team. Safani Taskas is our shader programmer. Cole Lewis, me, is our general programmer. Sofia Videva is our technical artist and rigger. Jack Weston is our producer and design director. Noah Kankanala is our sound design and composer. And our faculty advisors are Carl Rosendahl and Heather Kelly.
How much do you really know about the animal kingdom? Jack here is explaining to Sophia and Noah that elephants can hear sounds up to 600 miles away. Trouble is, he's completely wrong. Elephants actually hear using infrasound, but that's hard for you to understand. What if I told you I could expand your senses? Just reach out and try to grasp a new way to experience your world.
Yeah, so did you know that elephants use electric hairs in their eyeballs to find pollen? Or that elephants can sense vibration and locate other elephants underground? Squids can perceive anything and then transform into that. Each of these sensations are pretty downright magical, and there's countless others that are equally impossible to fathom as a human being. So VESP was our first step in turning the unimaginable into the imaginable. And we did that through an edutainment experience in VR, measuring that fantastical beauty of the senses with the limits of scientific reality.
You're more powerful than you think. Just like you take deeper sniffs of your favorite scent, bats can increase the power of their echolocation to detect different objects. Now you've done it. Make too much of a fuss in the ocean and you're seriously rocking the boat. Resourceful to the end. You've learned how to camouflage by adjusting the chromatophores of your squid, just like how you focus your eyes as a human in your world. Maybe next time you'll stay under the radar in open waters. You felt it in your bones, or maybe through the ground. That is the infrasonic sound that you can detect as an elephant. And maybe you aren't as alone as you think. You've learned echolocation and trust in your nature, in your environment. You now know that your survival can often depend on the objects in nature around you, that blending in can sometimes be the best way to come out ahead. And congrats, Noah. You listen closely to the ground to find your roots. In this case, your family. You never have to go it alone.
As we developed our prototypes, we began to run into walls while trying to completely embody our animals. Our first-person experience, the bee, proved to be uncomfortable in its movement. And because of this, we decided to format all of our animals as a third-person experience and changed our framework, this Mad Lib that you see here, as such. You and an animal will pursue a given objective using their sense. Before halves, we had chosen these 4 animals, and going through the Mad Lib, the bat can use ultrasonic to echolocate and find moths, the bee uses electrolocation to find pollinated flowers, the squid uses polarized light to camouflage, and the elephant can sense infrasonic to find its lost herd. For our final deliverable, however, we narrowed down to 3 experiences that embodied the biggest range of senses. Here, each animal is shown with its sense and its corresponding human sensory channel. Steph will dive deeper into that next.
Thanks, Sophia. In order to allow humans to process these senses as realistically as possible, we mapped them to different sensory channels. One part of how we mapped them was using shaders. In the bat portion of the experience, we needed to have a visual way to represent echolocation, since most people don't have the hearing required to understand what's going on when audio bounces off of objects in the environment. We used a shader to show what the bat could auditorily see, using pulses coming out from the bat during each echo. The squid experience was the easiest to map to a shader, since both polarization and chromatophores are visual. Squids use their polarized vision to see the exact color of objects underwater, and then they use their chromatophores to camouflage. We use a shader to increase the contrast in the environment for polarization, and then another to fade between textures and materials for chromatophores. Lastly, for the elephant experience, we dialed back on the visual representation of the specific sense, which is infrasonic. We wanted to be more reliant on audio and haptics, and visually, the only representation of sounds moving through the ground is a faint ring pulse that emanates from the elephant herd. Next, I'll pass it to Noah to talk about the auditory portion.
Thank you, Steph. So how do we use auditory cues to mirror these senses? Bats use echolocation to attain a spatiotemporal understanding of their environment. And it was challenging figuring out how to map echolocation to the human range of audition. We were able to do it by taking, manipulating, and processing a cricket chirp and using pitch shift to modulate the echolocation as the player increases the trigger rapidity on the controller. So in order to provide stronger oral feedback, we also added a spatial ping that resonates when the player echolocates a moth. As Steph has mentioned, the squid uses chromatophores to evade predators. At the start of the sprint, we pivoted to using a third-person camera angle, which enabled me to think about the emotional relationship between the guest and the animal. In this sprint, we wanted the player to experience the contrasting feelings of safety and fear that the squid feels as it navigates the depths of the Atlantic Ocean. So music is used as an analog to provide emotional context to these 2 contrasting states. And the elephant has excellent sonic haptic sensing and can produce and perceive infrasonic calls from miles away. So in this experience, we wanted to emphasize sonic and haptic feedback. There are 2 states, the infrasonic state and the non-infrasonic state. When the guest puts their hands to the ground, they have access to these infrasonic channels, which manifest as a series of rumbles, calls, and roars. And as the guest gets closer to the herd, the BGM becomes more full, evoking feelings of family and togetherness.
As Noah mentioned, our elephant prototype utilized a lot of haptics to convey their infrasonic sense. Originally, we focused on only audio and visuals to convey our senses. However, we are using a VR headset, so we had an additional sense we could utilize, touch. We gradually started incorporating more and more haptics into our experiences, until in the final prototype, we had variable vibration, where the haptics changed values based on information in game, and players were able to navigate using this. Throughout the semester, we had troubles and realized we needed to change how we did things. So just to highlight one aspect from each prototype, in the bat prototype, we are capturing ultrasonic, but we use a lot of visuals even though ultrasonic is audio focused, so it didn't feel like we were truly capturing the sense. After that, we started to integrate more haptics and audio into our prototypes. In the B prototype, the movement was too involved, which detracted from what we want to showcase. So later, we adjusted to have easier movement to allow players to focus more on other parts of the experience. In the Squid prototype, players didn't have a clear goal. Players would wander aimlessly and lose interest. We emphasized the goal through UI and docent to give players more purpose. Finally, in our Elephant prototype, our vibration mechanics were unintuitive to players. We wanted to use delay-based vibration similar to triangulation, which is how elephants use it in real life. Players were confused how to use it and didn't understand it. Ultimately, we ended up changing it to a magnitude slider, so the closer to a goal you are, the stronger it is, like a volume slider, but for vibration instead of sound. It was more relatable for players, and they were more able to navigate using it.
Which brings us to interaction design. So ideally, I think we wanted to use natural positive and negative feedback for the animals, but as Lewis said, that wasn't always enough to communicate to the guests. And there were major challenges that we hit along the way, and a lot of those related to the comfort or the ease of the guests in the world, and that prevented them from assisting them in the goals or reaching those goals as a guest.
You have your goals set ahead of you. You will have to collect dinner for your bat. Maybe it seems intimidating in the dark. But I believe in you. It's time to spread your wings as a diadem leaf-nosed bat. It's important to play, or in the case of this squid, swim. Jack will inflate and deflate this squid with water to propel it forward, but he better not get a big head. Noah, you're getting to know your companion in the savannah. I guarantee he'll never forget you, especially since he looks completely abandoned.
Yeah, so a big part of those clips are the UI. And so in the bat scene, we have the moths that you've captured in the jar on the left. And that was to fix this problem where you can't feel well fed as a bat because you're not one in VR. So that's something that we came up with as a way of dealing with that. The distance to herd on the infrasonic risk compass in the elephant scene showed how far away you were from your goal and which way was north. And we had a smartwatch monitor to show if your squid was safely hidden from predators and where the squid was if you lost it. So these could nod to the player to show them exactly what they were doing and how that was contributing to their overall experience and putting everything in context. And so that also added an educational component to it. And the docent that we mentioned before helped us solidify that educational component.
Before each prototype, we created a design document for each animal, researching its sensory capabilities, diet, and habitat, while I looked deeper into their movements, muscle systems, and skeleton for reading and animating them correctly. As a character artist, I had to make sure that the animals in our experience were interesting visually, but still informative and educational. Because while we abstracted the use of their senses to fit in VR, we still wanted their movements and look to remain realistic. In addition to making these models believable, we wanted to invoke the feeling of empathy with each animal in order to encourage the audience to help them use their sense. This is why I included animations for the bat landing on your controller and looking up at you, or the elephant trumpeting at different levels of emotion. In addition to that, I added models for the objectives, such as the hokey fish for the squid and the moth for the fox.
I know, it's a lot to take in. We may only have 5 senses, but there are so many more dimensions to our world than we've ever realized. You're lucky you can estimate what these animals can experience, from the tiniest bat to the squishiest squid to, yeah, elephants.
And yeah, that's the wrap of our project largely. So just to talk about some failures and important takeaways here. The free roam format did not work for us. We wanted to have people kind of explore this world themselves. That did not function well. We also decided that the first person perspective, which is what we had originally thought we would do, was too focused on locomotion because you had to move as the animal, and less focused on sense, which we didn't care about as much. So because we cared about sense, we wanted to emphasize that we removed the first person perspective, among other things. And in terms of the successes that we had, synesthetics were awesome. We had a synesthesia moment where you have all of your senses working together and there's the music in the background and it works out really well. We had the docent as a direct instructor who would slowly release information to you as you accomplish tasks. And pulling the person out of the animal actually gave us a unique opportunity for companionship, where you could bond with the animal and have empathy there, which is pretty impressive.
We've just scratched the surface of showcasing animal senses, and if we were to continue working on this, a way to do that would be by adding more animals and senses to give more points of view in the animal world. Another option would be to go deeper for each of the animals we currently have in our experience. For example, we could add in other parts of an elephant's life, such as avoiding poachers or finding a mate.
We began the semester with the goal to create an experience that allowed us to experience the world through the lens of an animal. And as Steph mentioned, we've barely scratched the surface of giving animal sensation to people. And what we found is that it's really hard to understand directly what these animals feel and to really be that animal. But we found that by being in an environment with this animal, helping them with the task, learning about the animal, and getting a glimpse of their sense and using it contextually, we hope that the player walks away from the experience with a transformation that informs the way they think about their environment and the world around them. And this is just one step into a direction of more exploration in this field. And thank you so much to all these individuals for helping us throughout our journey. We're grateful for all their assistance and guidance, and this project wouldn't be what it was without them.
We are now open for questions.
All right, great job, team. Congrats on your final presentation. Any questions? Just throw them in the chat. John, you're already there. Go for it, and Dave will help moderate.
So I confess I did not get a chance to try your piece, and I know that it's prototyping, and we always have this line. Are you teaching people how to use the thing from your promo, or does the docent do that? From the promo video you're showing us, telling us the educational part of this, but I don't know how to work the thing. So is there some way in your experience that you're teaching people how to work these things? I didn't get that from your pitch.
Yeah, Noah could probably talk more about this, but we have a docent that does explain this to people. Noah, do you want to take that?
Got it. That's what I needed to know, if that's what
Okay.
does it. Thanks.
Yes. The docent's in the game and explains things to you as you do them.
I've got a question about how you sort of brought the scientific accuracy. Can you speak a little bit more about the process you used of research and how you drew a line between what scientific reality you wanted to present and sort of where you needed to do more artistic interpretation? I'm sort of thinking specifically around, like, you talked about the look of the animals, but like environment design, like, I don't know, echolocation, chirping patterns, things like that.
I could speak to that. The biggest thing that we abstracted, I'd say, was the sense. So the environment and the movement and the models were all mostly accurate as, due to our research, but step shaders were kind of modified to help the guests experience it better and not just be confused with something that's not visual.
Yeah, so for specifically for the bat one, I'll use it as an example. We found some sort of like graphical explanations for how the echo actually comes out of the bat and how it like modulates it depending on how close or far objects are from it, and kind of use that to base our experience in. But then after like starting with that, just kind of building off of it to make it more applicable for the player and like easier to understand, because like I had mentioned, it's kind of hard to know exactly like if it's bouncing away from here or here, because our hearing isn't exactly as good as a bat's.
I would also add that like the electroreception for a bee and stuff like that, where the bees can't hear, knowing that the bees couldn't hear, we removed things that they would hear and replace it with vibrations and stuff like that. So I think we kind of kept that in too.
Mike has a question.
Yeah, you made a pretty big switch from you are the animal to you and the animal. But in your wrap up, you still said you can feel, you can be the animal. So I'm just curious about that question about empathy with the animal and what might have changed when it's you and the animal, and how did you care about still measuring empathy with the animal, or what changed with that switch to you and?
I can definitely take this one if no one else has an answer, but I would say that moving the person outside the animal was pretty necessary, because when you were the animal and you weren't moving, it was too difficult to use a lot of these senses, which were used largely for locomotion purposes. So if you were the bat, for instance, it would require you to flap or fly in some way, and that's not really comfortable in VR. And one of our design pillars was non-discomfort, so not making people feel uncomfortable like that. And if we wanted to make sure that the player was actually focused on the senses, we had to remove them from the animal and change their scale so that it would work well. And that was part of our experimentation and prototyping process that we discovered that in. But we did try the first person. We did try putting the person in the bee. And so much time was focused on flying around that they didn't really use the electroreception as much as we would like. So I would say that, yeah, that also did give empathy, and that was a side benefit, but we weren't doing it for that purpose. We just happened to notice that happened.
To add on to that, so we felt that you felt more empathy with the animal when you weren't the animal. Like when you were the animal, it felt a bit weird. It didn't really feel like you were interacting with an animal. It felt like you being an animal. It felt like you were just doing your own thing, and we're just giving you senses which you don't understand. With the animal being out there in the world, the player feels like they're themselves, and you're feeling like they're interacting with the animal when they're using the animal senses. So it increased empathy rather than decreasing empathy by putting the animal in the scene detached from you.
All right, that's time. Thanks, team, and congratulations on doing your final presentation. Good job. You can turn your cameras and mics off. We'll get you out of the spotlight. And Vercules, if you're ready, I will get you in the spotlight.
Okay.
All right, that's all of you. Whenever you're ready, you can go.
All right, let me just share my screen. All right. Hello, everyone. We are VERCules. This is our team. And our faculty advisors are Ricardo Washington and Dave Solbo, with Ricardo also doubling as our client for this project. And we are a discovery project creating a prototype that explores cognitive and physical training in virtual reality. What we're trying to do is discover if virtual reality could potentially be a good way to enable athletic training at home and explore ways in which cognitive training ideas can be used in physical training. So with that said, we'd like to show you our prototype demo. So with this demo, in this prototype, we created this rhythm exertion game that combines defensive and offensive combos into one experience. So we have the player doing what's called boxing flips and ducks, and this was inspired by boxers who train with pool noodles. The combinations you see here are combos that are coded in boxing that our expert gave us and our client gave us feedback on. They follow the natural momentum of the body and perform moves that require minimal reaction time. And this game was designed to incorporate moves that encourages cognitive capacities for training the players to recognize these moves so they are subconsciously knowing what moves to perform next. And we designed the art and UI with information processing in mind. That way, boxers can focus on their training while still assessing the situation around them. Due to the physical nature of the game, it would be difficult to share this live with you today. So if you're interested in seeing more, we'll be live demoing this Friday during final playthroughs. Now, I'll pass it off to Tini to talk a bit more about our design goals.
Thank you, Sally. Next, I'll go into a bit more detail on how we came to establish the design goals of this project. For this project, our client Ricardo came to us with specific requirements. We were required to pick a sport, dance, or martial art, and to focus on it for the rest of the semester. Second, we were tasked to build our prototype in virtual reality. And lastly, we were to create a prototype that combines both physical and cognitive training into one experience. While there are a lot of VR physical training games on the market, there isn't any that combines both cognitive and physical training into one. Next slide, please. Eventually, we chose boxing as our main focus and used cognitive terms to help us design. We ended up building two prototypes The first one is a punching bag combo training arena, and the second one, as you just watched, is a rhythm defensive boxing game. Next slide, please. Thanks to our client Ricardo, we were connected with a boxing expert and fitness instructor, Francis Braza. He offered many of his thoughts and experiences to help us design the prototypes better. We also kept presenting our prototypes to him and get his feedback on possible improvements. Thanks to him, we had valuable expert input and represent what real boxing training feels better. Next slide, please. Before we started building our prototypes, we thought of the limitation of VR for boxing training. First of all, Francis mentioned that stance and footwork play an important role in boxing, which cannot be readily tracked in VR. Secondly, the feeling of actually hitting an object and actually being hit cannot be generated with virtual reality. To solve these problems, we first decided to put our main focus on hands and heads as they can be tracked in VR. We then used visual and sound effects along with haptic feedback to try our best to simulate the actual boxing experience. Next slide, please. With that, we then researched on cognitive terms that can both be helpful for training boxers and for us to design the mechanics. For the first prototype, we focused mainly on these two terms. The first one is chunking, which means things make more sense when they are in chunks. The corresponding boxing action would be building boxing combos with different punches. Design-wise, after teaching player basic punches, we started to combine them together to form 3 or 4 punches combos to help them memorize and learn faster. The second term is automaticity. It means doing repetitive actions until it becomes automatic. That is very important for boxers because the faster they react, the better they can be at matches. In our game, we guide players through repetitive punching training and eventually prepared a timed challenge for them to check how well they perform. Next slide, please. For the second prototype, we chose to train players on their attention splitting and response inhibition abilities. The corresponding actions for split attention in boxing is to dodge and punch at the same time. A famous professional boxer, Floyd Mayweather, once said, "I'm a boxer who believes that the object of the sport is to hit and not get hit." This term helped us settle down on a prototype in which players need to take care of hitting the incoming pads with the right punches, as well as avoiding being hit by the pool noodles. For response inhibition, it is somehow similar to automaticity. In boxing, it plays the most with helping boxers generate their next move based on the natural momentum of their bodies. Because of that, we did several playtests after we established the basic level design. After this playtest, we changed sections that contain weird movements, such as a left jab after a left hook. Next slide, please. As previously mentioned, we were also highly inspired by the pool noodle training method for boxing. As you can see from the GIF, trainers hold 2 pool noodles as obstacles for their trainees, and their trainees need to do punches while performing defensive moves to avoid the pool noodles. Next slide, please. Under the guidance of Francis and cognitive terms, we built our 2 prototypes as previously showed. Here are some fragments of the patterns we train our boxers on. In prototype 1, players only practice aggressive punches to launch them faster and faster. And in prototype 2, players need to also be aware of incoming threats and do defensive moves. Next, I'll pass to Cheryl to talk about our effort on improving the user experience.
Thanks, Tony. So one feedback we got from staffs was the confusing color coordination in the game scene. As shown on the left, the neon colors are vibrating against the background. So we published our environment by desaturating the background to separate it from the play area. In our both prototypes, we took inspiration using authentic boxing elements to get our players situated in an environment like using the boxing ring and the pads. Additionally, to guide our audience through VR, we designed our onboarding tutorial using minimal but necessary information, so they can accustom to proper boxing techniques. In prototype 1, we created sound effects for hitting the punching bag, like the wish sound for waving arms in the air. As mentioned before, VR cannot generate the feeling of actually hitting the target. So we use sound effects to facilitate that simulation of actually boxing training. We also had some simple call instructions to better guide the players and to give them positive feedback if they perform correctly. In the second prototype, as is a rhythm exertion experience, music plays an important role. Francis once mentioned that boxing is a lot like dancing. So music helps boxers keep focused if they fall out of rhythm during a match. Thus, we utilize music to establish rhythm and keep players on beat. We designed the whole level based on a beat we create so that every hit dodge actions are on beat, which greatly generates the playability of that game. Next, I'll pass to Quan to talk about the technical challenges we overcame.
Thank you, Shara. So our first concern is how to recognize punch and dodge movements. Because the movements vary widely with the hit position, standing posture, and even player's habit, it's really hard for us to tell whether the players are doing standard movements. So instead of that, we focus on the basic requirements and differences of the movements. For example, if the hand speed is fast enough and the collision position is in the right range, the action would be recognized as a punch. Our second concern is how to provide proper feedbacks. Luckily, the controller vibration provides a very good feedback for punches, and with the help of sound and visual signal, even some elements like punch wind can be duplicated in VR. We could still, to some extent, simulate the environment and give proper feedbacks. For example, a fixed model passing by player's head with a whoosh sound should be enough to indicate a successful slip. The third problem is how to show instructions in the training. At first, we use animations. However, when we speed up the training, reading instructions became extremely hard, so we use the block design as a complement. For example, J pad are red, crosses are blue, and hooks are yellow, so the players could know the next instruction based on the pad color. Not only that, level design-wise, we also streamline the combos to make sure the movement transition is smooth and intuitive. And Eileen's gonna talk more about implementation.
Thanks, Quan. So the two major mechanisms of the first prototype is the combo generation and hand tracking we use for punch recognition. Instead of generating the combinations automatically, we hard-coded the combos into our code according to the result that the boxing coach gave us. Next, we had to resolve the issue of hand tracking and punch recognition. Initially, we used Oculus Quest's camera to track the hands instead of the controller. We believe that by removing the controller, it will be better to simulate the feeling of training in the gym. However, one of the major drawbacks is that the camera's tracking speed is not fast enough. This hindered the punch recognition, and thus we introduced the controller back into our prototypes. This greatly improved the detection speed. We also made iterations on punch recognition. Initially, we used displacement of controllers. However, this interfered with playtesting as we had playtesters with various height. Then we decided to compare the X and Y component of the punch velocity to determine the type of the punch. This detection mechanism is more accurate than the first model. The playtest done by the client and the student also exposed some problem with the punch recognition. We recognized that the issue was with the starting point of the punch recognition, so that we adjusted the mechanism to constantly monitor the speed of the controller, and as a result, the punch detection was much more accurate. For the second prototype, we did a lot of iterations on the pool noodle placement and block spawning. Initially, we designed the game with 2 pool noodles. However, after several playtests, we find it would be difficult for players of different heights. Thus, we decided to use only 1 pool noodle and the blocks to let the player know when to dodge. We noticed that it performed just as good for dodging, and the distance is a lot easier to adjust. We also tried to match the spawn of the block and the block speed by matching with specific frame numbers. However, in the group playtest showed us that the frame per second varies on different machines, so instead we matched the music tempo to fix this issue. And then I'll hand back to Sally to talk about the last steps.
Great, thank you, Elin. So for our last steps, we learned a lot over the course of the semester, one of which was playtesting. Since we are designing an experience for boxers and have no way to kind of get boxers to playtest with us, we decided to kind of shift our iteration based on who we had the most access to and we playtested with our friends, our crewmates, clients, and even his class. So when we iterated, we were working with 3 audiences: our expert, our target audience, which are boxers, which we didn't have access to, and our playtest audience in mind, who are not boxers. And we did most of our iteration based on our client and expert feedback. And we used our playtesters more on implementation iteration. So when we showed our prototype to our expert, he had a lot to say about it. He confirmed that he'd never seen anything like this before and that our patterns really followed boxing training accurately. He believes that this would actually be good training for mid-tier boxers, and he also gave us some ideas of how we could move forward in the future with this to make it more advanced for future boxers. So one of the things we learned in terms of our goals for this semester was we definitely believe that virtual reality is definitely a viable option for cognitive physical training. We found that with our prototypes, we could combine different training methods that would otherwise be difficult to do in person. So we discovered that VR really lets us overlap a lot of information from the sound, art, and UI to kind of create a truly unique training experience. And because we discovered that VR lets you overlap a lot of information into a single experience, we think that it'd be interesting to explore that information processing in other ways in the future. Like how much information can we process in a single experience and what other ways can we apply that in other scenarios? In addition, we mainly focused on boxing this semester, but we believe that there's actually a lot of potential with other sports as well. One of the things that made boxing work well for this project was that fact that there's actually a lot of skill required in the ring that would benefit from cognitive training. We believe that other sports, for example, fencing would be a good pick because that involves a lot of strategy, but say bowling wouldn't be a good pick because that's more based on muscle memory. And for our last steps, we're archiving what we learned, created, and handing everything off to our client. He really believes that this is only a small part of the research that we've done. It leaves a lot of room for future exploration and can help him determine what will be a good avenue to explore next. And these are our metrics. We are prototyping gameplay interactivity and client requirements. And we are VERCules. We are a discovery project creating prototypes that explore cognitive and physical training in virtual reality. And thank you. We are now open for questions.
All right. Hey, congratulations, team, on your final presentation. Good job. Any questions? Just throw them in the chat. Ralph, I see you already have one.
Yeah.
Dave, can I moderate?
Thank you. So, is your client the boxer or the trainer? Is he planning on actually using this in the gym?
So when we were creating this project, our client is Ricardo, but we were creating this project in mind, like potentially in the future that it could be something that would be used like with a trainer. So right now, the question is like we're not creating this for a trainer, but in the future, like we're definitely thinking about exploring that possibility in the future.
So this project won't be used, is what you're saying, right? I mean, there's no plans for it to be implemented in any way, correct?
Yes.
And one other question, Sally, did you learn how to box?
I think I'm more informed about boxing, definitely.
Thank you.
Steve, you have a question?
Tell me about the design rationale behind the background. Like, how did you come up with that? Was this through user testing, or there's some idea about a techno cityscape? Like, how did that play out?
For our second prototype, for the background, we kind of, because we wanted to create like more of a music rhythm game, it's mostly due to like we kind of want to have fun with it. So we decided on the cyberpunk kind of techno background. Mostly like one of our feedback was like, especially from our boxer and our client, was just to make something like gamify it, make it fun. So that was mostly just us having creative freedom to kind of like explore like how can we make this an interesting experience while still like making using actual boxing training. So that was just more like creative.
So it was just purely like just make something cool, or was it somehow connected? It's like this would go with the idea of boxing, or is it purely like make it interesting and that's the only consideration?
It definitely helped with like information processing, like with color coordination. So like we said earlier, we use different colors to kind of suggest different moves and like also help coordinate the entire scene. So it was also like beneficial for helping us, like because most of our playtesters were not boxers, it helped them understand the gameplay better and understand what to do.
Mike, you have a question?
Yeah, you talked through a bit the improving accuracy in punching. Can you talk about numbers maybe about the accuracy of slipping left or slipping right and knowing the direction of the slip, and whether you have some numbers showing that you've improved your accuracy over time, the precision and recall of slip direction?
So yeah, so for the midterm, we are trying to verify the user is they doing the standard punch, but later we found that it's really difficult for us to do that, because it's very widely when they punch with different posture, like hit a different position. So for now, we mainly focus on to tell the difference between each punch. So I can we haven't have a number to prove it, but I believe that for now, if the user are doing a standard punch, the precision would be very close to 100%, because we only test the very basic requirements for the punch. So that's why how we improve the precision, and yeah,
And the
basically
slip?
like that.
Are you getting the slip direction?
Yeah, so for the slip, like for the slip for now, we only detect if the user are hit by the pole noodle or the rod, and if the user are going in the correct direction, there are the only two basic requirements we are test during the dodge. So like I said, for now, yeah, as long as the user successfully slip, it will be recognized 100%.
Bob, you have a question?
Yes. So there's a lot of research that X-ray games actually improves cognitive function and just improves cognition in general. Did you guys experience that or see anything like that in your playtests, or you found something similar?
So for this project, we're not cognitive experts, so we have no real definitive way of kind of testing for cognition. So
yeah, I guess.
Yeah, so for this project, we mostly kind of observed improvement over time. So as a group playtest and our client playtest, we definitely focused on that improvement, and really like that over time that people will improve with our prototypes.
When you mean improve as an improved playing, the research entails that they improve in studies as well. They improve like in the classroom if you're just doing exercise games. I'm wondering if you guys actually got better in courses when you played this.
If you wondered if we got, what was the question?
So basically, so it's a very broad tangent, but
yeah,
the theory is that if you're playing exercise games, you actually get better in the classroom. You actually study better, and you actually function better. Did you guys experience that?
I believe that as a group, we did improve better over time, mostly because yeah, I just feel like over time as we kept playing it, there was a lot of we as a group just improved better. And also our client also believes that he saw some improvement as well as he was playtesting it.
Okay, all right, thank you.
All right, that's time. Congratulations, team, on your final presentation. Good job. You can turn your cameras and mics off. We'll get you out of the spotlight. And if Archive Dive can get their cameras and mics on, I will get them in the spotlight. All right, that's all of you. Whenever you're ready.
Right, good morning. I just want to do a quick sound test before we start. Did you hear it? All right.
Yes.
All right. So, good morning. We are Team Archive Dive, and this is our final presentation. Our team instructors are Mike Christel and Ralph Vitocchio. Here are all our team members. Our client, the History Makers, contain a database of 150,000 stories from almost 3,000 African Americans in the form of first-person interview. What they need from us is to build an experience that gets young people to use their database and learn from that. And also the experience presents the data in a visually attractive manner, and the experience works on across platform. That is, it works on all mobile and desktop devices. Our goal for the project is to build a web browser experience which is fun, interactive, and is visually attractive. It allows quick filtering of large sets of data and encourages the 20 to 29 years old to learn from the History Makers database. Our ultimate goal is to deliver a highly polished and usable product to our client. Now I'll introduce Yue to talk about our design and process.
Thank you, Anjali. And welcome to meet our persona, Sarah. Sarah is a 23 years old a college student, and the recent Black Lives Matters makes she realize that she's lacking the knowledge of African American stories. So when she browsing the content related to movement, and she visit the History Makers website. However, the sheer amount of videos overwhelmed her, and she did not know where to start. So she just clicked the first couple of History Makers and never has the patience to see rest of the profiles. And at the same time, it's really hard for her to find History Makers that are related to her personal interest because of the limited display information. And at last, Sarah complains that website looks too academic and research focused, so it's not really attractive for her. And with all the problem in mind, our final product should provide the starting point for user to find someone aligned to their personal interest and at the same time visually appealing to young audience. So for the half, we came up an idea by associating the data we had with user needs, but the problem is our client said they do not wish to show the video anymore because of the paywall issue. So we decided to pivot away from showing videos, focusing instead of presenting the people and their information in a clear and playful way. So we broke the projector down into two parts. First is the rotation of feet. We put the rotation in the picture carousel, and the user can click through the ring of the image to see all the matches. And the second is in the way that users slide. They can select the filters, but we made the filters flat stripped and keep the dragging component. And here's our final design. We have the image ring on the left and the information biography on the right side and the filter system down below. And we did a lot of playtests to iterate our design. One of the observations we found is that most of users try to click the biggest tile in the center unconsciously, and they just wanted to learn more about this person. But actually the information is on the right side. So our assumption is that people's attention is all cut off by the ring and ignore the information on the side. So how can we catch people's attention to see the biography was our challenge. Many people might question us, why don't we just directly let user to click the tile? And we did. But the thing is, it's easy for user to accidentally misclick the image and the pop-up will disrupt their experience. So we tried another way to solve the problem. So we added fade in and fade out effect to the biography information so the animation will catch users' attention. Now I will introduce Lauren to talk about our demo.
So this is the landing page you come to when you first enter our website. And our experience is centered around playing with filters to narrow down the set of people you're looking at. So here we have maker category, which is like their sort of field or occupation and birth decade. And you can see that you can play around with these filters in a couple different ways. And you can also change the filters you're given. So I'm from California, so I think I'd like to look at people born in the West. And I'm really interested in art, so I want to look at art makers. So then I can explore this ring of people who match these two filters. And there's like a couple different interactions for that too. I can check out their occupation on their title card and the short bio to see if they're interesting for me. So Maury Turner is a cartoonist, and I really like cartoons. So I might want to check out his bio on the History Makers website now. But let's say I'm a little less lucky and I'm looking through this ring and I'm not really finding anyone I think is interesting. In that case, I can look at smaller subsets of this group. And here we give you another set of filters that let you visualize the subset. So you could do it by gender, for example. And you can see it's pretty cool that there's a lot of female art makers born in the West. You can also do favorite season or color. I like fall, so I might like to go further down and look at individuals who like fall. A lot of faculty asked us why we chose favorite color and favorite season. And a big part of it was because the client had that in their database and they wanted to showcase that. But it does also have the potential to make the experience interesting to a wider variety of people. So again, you can make your way to the History Makers website. So another part was having a mobile version, just so like more people could experience this also. And it has basically all the same functions as the desktop. You can play with the filters, browse the ring, and visualize the smaller subsets. So exploring a data set of this size is always going to take a long time. So our experience kind of makes that process of filtering and browsing more engaging, like throughout the whole process. That way, if you're like, you have that spark of interest without the specific academic focus, you can still like find someone you like. So I'm going to let Suchi talk more about our work in depth.
All right, thank you, Lauren. So I will show our work in detail. So the first is to be robust. So we want our experience works well in many different situations. So to achieve this, we did three things: platforms, responsive, and multiple solutions for one point. Let me give you some examples. So yeah, we find mobile platform is very different in terms of screen size and interaction. So in this example, when you have a bigger screen, you use a mouse to click the small headshot and get the information. But when you have a smaller screen on your phone, so you instead use your finger to swipe the screen and to scroll the list. And this is just one of the examples. We just have separate designs for different platforms, and that's a lot of work. And as for responsive, one kind of responsive is pretty straightforward. When you resize a window, no matter it's very wide or normal size, very narrow, or even unreasonable size, you will never get a very broken, like UI in our experience. And another type of responsive is more complicated. So in this example, we have a bar chart. So this bar chart looks well when it only have 2 rows. But what if you have a smaller screen? So in this way, part of the bar chart will cut out. So instead, we put some blocks in the second rows. And there are also some cases that you have too many rows in the screen. So in this case, we pack them into a grid and in order to fit into our screen. And next is multiple solutions. You might not notice there are actually 2 solutions in our ring. So one is that the number is very small. The space is uniform between the cards. It looks well. But what if the number is very big? Let's say 400. So in this case, you can see that in the back, it looks like an infinite ring, but in the front, you still have enough space. Another example is our data visualization. So next. Yeah, so in our data visualization, we have a pie chart. And when the number is very small, as you can see in the middle, it's totally broken. Again, our solution is have multiple solutions. In this case, we bring a bar chart. So next is to be playful, and we have a lot of 3D rendering, 3D animation, 3D interaction. So this is a little bit of tricky in the website. So we did our research. We built our codes based on existing libraries, techniques such as 3JS, TwinJS, and also for some parts, we have our own implementations. And next is to be polished. And this is a lot of work. So we have 10 big versions. Each version means a lot of design and decision changes. We have over 30 small versions. Each small version is a loop of internal playtest, feedback, and iteration. We have 5 prototype projects and completely over 200 texts. And next is to be deliverable. So at last 2 weeks, we realized our clients is going to deploy our projects. So we work with their developers to make sure they can host our experience and maintain our experience in the future. And we deliver our code. We had our code review and we provide documentation. And next, I'll introduce Lauren to talk about reflection.
Yeah, so these are our top 3 metrics for success: quality assurance, interactivity, and prototyping. So around halves, we decided there were 3 things we really wanted to focus on: personal discovery for the user, having playful interactions, and making sure the product works in a variety of situations. So the way we achieved this was having a lot of quick sprints, as well as small iterations in between. This way we can think through all the design and implementation decisions in depth, which lets us get that interactivity going and have a polished experience in the end. The second point was having frequent communication with the instructors and client on how to respectively portray this collection of notable African Americans. We needed to be aware of our lack of knowledge on the context and avoid having careless design decisions detract from the overall experience. So the result is that at Softs, we heard feedback that aligned very well for metrics, that it was polished, and people wanted to keep clicking. And the client is also satisfied with our product. As you can see, it's already on their website. So you can just click that and go to our experience. And I can let them speak for themselves on this.
13. I'm beyond pleased with the result. It just became magic, and to really develop something that everybody, professionals are excited about, and everybody who sees it is excited about what it adds and how it makes things accessible in another way. I think you hit it on all cylinders. You've done a marvelous job.
It was very well organized. It included everything, as far as data goes, it was pretty easy to include the whole collection of our interviews. And so that was good. The data and functionality, I think, is there. The look and feel looks really good too. Some of the small iterations that we did, I think, help a lot. I'm fairly surprised that we can just put it up, and I don't think there's going to be any concern for things like that. Did a really good job, honestly. I really do. I hope you get a good grade on your assignment too.
You did a great job. Your entire team kept us informed every step of the way. And I am just amazed at how it progressed from the very first set of mock-ups to what we have now. I'm hoping that it stays with them, the experience that they're working on as they play around with the tool, that it'll encourage them to continue to come back.
Surprised I was with the level of detail and the completeness of vision, I think, that you guys came to. The handoff process was extremely smooth. Good work on the documentation, and at the end, it was very easy to follow for me to rebuild the application locally. Again, fabulous work, fabulous work.
Cool. And I'll let Shiwen wrap up for us.
Yeah, sure. Thank you, Lauren. Here's what we learned from this semester-long project. First thing is we come to understand the importance of the iterative design process. Actually ensures very quick feedbacks and faster development time. Another thing that we learned to hold extra meetings for different roles, which means that we have internal meetings of designers and programmers so that we can maximize the limited group meeting time. And then we come to understand how to find a balance point between different stakeholders. For example, we need to balance out the client requirements, instructors' feedbacks, and playtesting results. And last, we learn how to communicate with the clients as well. Since a lot of the early prototype looks really rough to non-tech and design people, so how can we convince clients to have confidence on us is a huge lesson that we learned. And at last, we would like to give our special thanks to Brian, who helped out with the code review handoff process, John for setting up the playtesting, and Shirley for typography and layout. and all the ETC staff and faculty for their helps about feedback and help. And that's the end of our presentation. We are open to any questions you may have.
All right, congratulations team on your final presentation. I see questions are, I think Scott, you're up first and Dave can help moderate.
Yeah, nice work. One question, in the example you had where you had 400 returns from the drill down to the south, it would be really nice if I was interested in, say, someone from Atlanta to be able to do a text search. Did you think about that, and do you allow it, or if not, why not?
All right, so we had that kind of request from the client a lot. We had to strike a balance between like really robust filtering and searching and most people not caring about that immediately. So we kind of intentionally left the experience a little more simple.
Okay, thanks.
Oh, yeah. So your goal was to get folks who are 20 to 29 years old visiting the page, interacting with it more. Did you have any kind of like key performance indicator or single metric that you were trying to move? And did you run any analytics on that? And if you didn't, what would you do to measure this?
Yeah, so I think we have some qualitative results. For example, one thing is that we want to ask if people actually find people their history maker they're interested in, and then at the end of each playtest, we will ask them to find some history maker they might be interested in but do not know before. And most of the people ended up finding someone they're interested in. So I think that's a good indicator of the success of how successful our product is. And in terms of quantitative data, so our website is already integrated into the history makers website, and they have a Google Analytics to give us more in-depth data. So one data we will be expecting to see that in the original website, most people will just ended up clicking the first couple of the history maker with last name started with A. So it will give a really uneven distributed data, because most people will click the first couple too. So I think by introducing our website, so the distribution will be more evenly so that that's the result we expect to see. But I think we'll get a result from the history makers in about a few months, so that we can know how successful that is.
Thank you.
Yes. Could you, if you were to give another ETC team a piece of advice about how to begin to understand a culture that is not your own, is there one thing you would tell them to do?
Well, I think the solution in this case was to avoid any providing our own content. We just provided the framework to let the content speak for itself, and that's partly because that was the best solution for this particular client. So I think the advice might be to, one, know what your client is expecting, and two, if it's something like this, let the content stand on its own.
And we'll also let them be cautious about being careful with the theme, so that they are not culturally inappropriate in any way, and they know how to handle the theme before they start the project.
And
thank you. It's a tough challenge for anybody, so I appreciate that you were sensitive to it.
Ricardo?
Yeah, hey, good job, team. On a lot of levels, I think one thing that you guys did really smart was choosing different graph types when you had changes in the, in the number of cards. I was wondering, did you guys have any recommendations for the client going forward on how to handle that with the carousel itself? I noticed if there was one or two entries, it felt really barren on the carousel. And again, that's not something that you could solve, but did you have any recommendations for how they could deal with low numbers on the carousel itself.
I think we we honestly did not like think that was a big problem to like address compared to some other things. So
but like we have a really but we have another suggestion for our client is to focus on the social media part, because from our research we found like most of young people, they're using the social platform a lot, so probably that's a great point for them to track different history makers.
All right, that's time. Thanks, team. Congratulations on your final presentation. Good job. Oh, Anjali looks like she has one thing she wants to say.
Yeah. So I'm putting the link of our build and the survey in the chat, and I would request, if possible, if you could fill the survey, that would be great.
Thanks so much. We'll take a look. We got it in the chat, everyone. So congratulations to Archive Dive. Congratulations to all the teams. Great job on finals on Zoom this semester. So you all have a great rest of your day. We'll see you at final playthroughs tomorrow. And faculty, we'll see you in another Zoom soon. Thanks, everyone. Take care.